Okay, let's go over homework 3.3, 3.4, number 3, right? So we have this function f of x is given, which is a rational function, and we want to find the relative max and relative min and the points of inflection and sketch the graph. All right, so let's do that. All right, so we need to take the derivative so that we can find critical numbers. All right, so you have f prime of x is equal to, we can use a quotient rule, so square the bottom, so quantity x squared minus 4 squared, right? Then derivative of the top is 0, so 0 times anything is 0, minus, right, top 4 times derivative of the bottom, which is 2x, right? So this is going to be simply negative 8x on top over quantity x squared minus 4 squared, right? Then we can just set that equal to 0. Then we see that, so we can just set negative 8x equal to 0. Then divide through by negative 8, which gives you x equals 0. Right? So that will be our critical number. Right? And when x equals 2, or positive 2 or negative 2, the denominator becomes 0, but the positive 2 or negative 2 is not included in the domain, so they cannot be a critical number. All right, so a critical number is 0, so we have to determine if it's a local max or local min. I'm going to go ahead and take the derivative again, then apply the second derivative test. So f double prime of x is equal to, right, it could be a little bit messy, but take the derivative of that, right? I'm going to put negative 8 right in front, right? Then quotient rule again, quantity x squared minus 4 raise it to the 4th power, right? Then the derivative of the top is 1 times the bottom is quantity x squared minus 4 squared minus top is x, then times the derivative of the bottom, so 2 in front, keep the same quantity x squared minus 4, and multiply by derivative inside, which is 2x. Right, so clean up a little bit, right? So negative 8 is still there, right? Then you have a big fraction, right? So I keep the denominator as it is for now. All right. Then let's see what's in common. So you have x squared minus 4 is in common, so I'll pull that out. So x squared minus 4. Right, so I took one of these guys out, so I circled 2 so that I know that there's another one. Right, then I factor this guy out. Right, so what's left is you have another x squared minus 4. Right, so that will take care of this guy. Right, from here you have 2x times another 2x, so it's going to be negative 4x squared. Right, so we'll get right, first we can cancel one of the quantity x squared minus 4 and cancel that and turn into cubed, so it's negative 8 times, All right, so a negative x squared and a negative 4x squared is negative 3x squared, and you have a minus 4. Right, then you have x squared minus 4 to the cubed. Right, since there are a whole bunch of negative signs, so I'm going to just incorporate this negative sign, turn into plus sign here and plus sign there. So you have just 8 times 3x squared plus 4 over quantity x squared minus 4 raise it to the third power. Right, so this is the second derivative. Right, so let's plug in 0 because critical number is 0. So second derivative at 0. Right, so if you plug in 0 here, it's going to be positive on top. Right, and plug in 0 here, so it's negative 4 cubed is negative. So positive divided by negative is definitely negative. Right, which means that we have a concave down shape, which means that f of 0 is going to be a local maximum by second derivative test. Right, let's find f of 0. Right, f of 0 is going to be 4 over negative 4, so which is negative 1. Right, so let's type in the answer. All right, so relative max happens at 0, comma, the function value is negative 1. All right, and relative min, it does not exist, so D and E. All right, find the point of inflection. So if you look at the second derivative, you can see that this is never 0 because the numerator is never 0. So we do not have a point of inflection. So type in D and E. All right, then we can just sketch the graph using Geogebra. So open up Geogebra. Then y is equal to 4 over x squared minus 4. Right? Was that the equation? Let's go back. Yep. So right, then hit enter. All right, so this is the picture. All right, so we can find, so you have going like this, and you have concave down shape in the middle. All right, let's pick the right graph. All right, so this looks promising, and let's see anything else. Nope, this is the only one, so this got to be it. All right, let's check the answer by submit for testing. Okay, it came back. Looks like we got all of these correctly. All right, that's it. I hope that this was clear.